Forming quadratic equations in geometry. Quadratic expressions look like this. The highest power of x is 2, in other words x squared, and a, b and c are constants. It could be integers, decimals or fractions, and one or more constant could equal 0. So this is a quadratic, this is one as well, and so are all of these examples of quadratic equations. If they're set equal to something, these expressions will become quadratic equations, and then, if they're rearranged to equal 0, they can be solved. This nugget is going to look at how we can create quadratic expressions and equations from geometry problems. In this question, we are told a rectangle has sides of length x minus 6 centimetres and 2x plus 7 centimetres. And we are asked to write an expression for the area of rectangle ABCD in the form ax squared plus bx plus c. As this question is about the area of a rectangle, we know that the formula to use is area equals length times width. If our length were just integers, we would simply multiply them together. However, in this situation, we have algebraic expressions instead. But let's just do the same thing and substitute those values in. So, our area equals our length of 2x plus 7, multiplied by the width, which was x minus 6. We know that when we multiply algebraic expressions together like this, they should be written in brackets like this. So now it just becomes an expanding brackets question. Doing this, we get 2x squared minus 12x add 7x minus 42. Collecting like terms makes this 2x squared minus 5x minus 42. And this is the expression in the form we needed, ax squared plus bx plus c. Remembering that a, b or c could be negatives like we have here. The expression for the area that they asked for is 2x squared minus 5x minus 42. In this question, we are told that a right-angled triangle has sides of length 3x plus 2 and x plus 4. And this time we're also told that the area of the triangle is 20 centimetres squared. We're asked to write an equation for the area of the triangle in the form ax squared plus bx plus c equals 0, where a, b and c are integers. We will approach this in exactly the same way as writing an expression. So first, let's choose the formula that we're going to use. And for a triangle, area is half times base times height. Next, we substitute in the values of base and height, which are the two lengths given. And we know they're perpendicular because it's a right-angled triangle. So the formula becomes half times 3x plus 2 times x plus 4. Let's rewrite this using brackets like we normally see when multiplying expressions. And let's use the skill of expanding brackets to get this. And again, we'll collect like terms to get the area is half times by 3x squared add 14x add 8. Multiplying the whole quadratic by a half means we just need to halve each constant. So we get that the area is 1.5x squared add 7x add 4. So far, we have an expression for the area, but we want an equation and have more information. We are told that the area is 20 centimetres squared, so we can set our expression equal to this value. So let's take that expression that we made for area and set it equal to 20. And this is almost the format that we were asked for. However, we need it to be equal to 0. We can make our equation equal to 0 by subtracting 20 from each side to give us 1.5x squared add 7x minus 16 equals 0. The question also asked for a, b and c to be integers. The easiest way to make all of these constant integers without making them large number very large numbers is by doubling. So timesing by 2, we get 3x squared add 14x minus 32 equals 0, which is the format that we want. So an equation for the area of the triangle in the format asked for is 3x squared add 14x minus 32 equals 0.